Good afternoon, my dear student. Today we will try to understand the driving point impedance and transfer impedance. About these two quantity which are associated with a circuit, I mean a complex network or two-port network. So far we have discussed about circuit consists of resistor, capacitor or inductor. If circuit consists of impedance, complex term, impedance, then we need to understand two factors. One is driving point impedance and another one is transfer impedance. First, let me tell you what is driving point impedance. Driving point impedance is nothing but ratio of source voltage and source current. Ratio of source voltage and source current. The driving point impedance for a network can be defined as impedance is the ratio of source voltage to source current. Okay, source current. This factor is also known as input impedance. This factor is also known as input impedance. What is a driving point impedance? The driving point impedance is nothing but a ratio of source voltage to source current or supply voltage to the input current of the circuit. You see, everyone see the given circuit. You see this circuit has two loops, and for the input loop you see there is a source voltage exists, and it is denoted by E1. An AC source, obviously not DC source, an AC source is applied to the input or to the loop 1 or mesh 1 through is I1 current flow. Okay, now let me tell you what is transfer impedance. What is transfer impedance? Transfer impedance is defined as the ratio of source voltage, or ratio of voltage, you can write voltage in one mesh to the current in another mesh. Not one, which one we have considered in which a voltage source present, except that one if we consider another mesh or second one. For this case, for the given circuit, if we consider mesh 1 in which supply voltage applied, and mesh 2 the current I2 current flows. The ratio of these two terms is known as transfer impedance. So we can mathematically write it, the mathematical representation of transfer impedance. So transfer impedance T, we have considered two loop 1 2 equal to E1 divided by I2, and one condition here, others you write Z here. Actually impedance always represented by a letter Z, capital. So therefore the transfer impedance is the ratio of voltage in one loop to current in another loop. This is the transfer impedance. Okay, so first everyone try to understand the basic or fundamental difference between impedance and resistance or reactance. I hope everyone has a good concept about this term. So what is impedance, what is reactance, and what is resistance? We have discussed about this quantity in previous classes. Today our objective is to understand what is the driving point impedance and what is transfer impedance. Also we will try to understand what is transfer admittance and what is driving point admittance. Everyone knows that admittance is nothing but the reciprocal of impedance, the reciprocal of impedance. So if I ask you what is driving point admittance, then you can say that driving point admittance is nothing but the reciprocal of driving point impedance. Similarly, if you can give answer if I ask you what is transfer admittance, then the answer will be the transfer admittance is the reciprocal of transfer impedance. So let me write these two terms. One is let me write it. What is driving point admittance and driving transfer admittance? Driving point admittance is nothing but the reciprocal of driving point impedance. If you denote the driving point impedance like that, capital Z, driving point impedance Z, capital Z, this is also known as input impedance. So let me write here a Z in equal to E1 divided by I1. Everyone please look at the expression of driving point impedance, which is nothing but the ratio of input voltage and input current. So therefore, driving point admittance, you can write expression of driving point admittance is as I1 divided by E1. Now let me write the expression of transfer transferred admittance. Transferred admittance is the reciprocal of transfer admittance. So I hope everyone knows about this little bit, or few student knows in details about impedance, admittance. কি করে এটাকে off করবে? Block কি করে করা যায়? Admittance. Okay, so now everyone write or derive the expression of driving point impedance and transfer impedance for the given circuit. My next question is that everyone try to derive the expression of driving point impedance as well as transfer impedance for the given circuit. Okay, and before going to derive the expression of these two terms, driving point impedance and driving point and transfer impedance, let me tell you what are the importance of this quantity or of these terms. What are the significance driving point? Why do we need to study about this quantity, driving point impedance or driving point impedance or transfer impedance? Actually, everyone has noticed that for amplification purpose, for the purpose of amplification of a signal, we use an amplifier, and you know amplifier is nothing but a special arrangement of transistor, special arrangement of a transistor, but there is a biasing condition, everything, and there is a active region we consider. So to amplify a given signal, we consider or we use an amplifier. An amplifier is designed by using transistor or FET, BJT or MOSFET. Okay, so that time we have noticed that to increase the gain of a transistor, we use or we connect several transistors in cascade connection or in series connection to increase or enhance the gain. Gain means current gain, beta. Current gain of an amplifier, we consider a combined or we consider a combination of several transistor or amplifier in cascade connection. So you know this cascade connection, the overall gain of the cascade connection is nothing but the product of individual gain of the amplifier. To design such a cascade from of amplifier, we need to know their driving point impedance and also transfer impedance. If you connect several transistors in cascade form in order to increase the gain of the overall system. We need to know the impedance, driving point impedance as well as transfer impedance to avoid the mismatch condition, of this transistor. Okay, so here we have considered passive components instead of active component, and we generalize this thing using impedance parameter. We do not consider here particular resistance, capacitance, inductance. So far we have discussed. Now we actually try to generalize the circuit function in terms of impedance or admittance. Okay, if anyone has any confusion regarding transfer impedance or driving point impedance or admittance, you let me know. Okay, now everyone try to derive the expression of driving point impedance as well as transfer impedance for the given circuit. If you able to derive the transfer impedance and driving point impedance, then you can easily derive the expression of admittance, driving point admittance or transfer admittance. Okay, so for this circuit, you derive the expression of driving point impedance or input impedance. Driving point impedance or input impedance of the given circuit. Input impedance, let me denote it ZIN. Okay, in ZIN. Now we will derive the expression of Zin. Zin okay, so Zin equal to, we can write E1 by I1. Zin equal to E1 by I1. Now for the given circuit, you tell me what will be the expression for the ratio of E1 and I1. One thing everyone remember that to derive the expression of driving point impedance or transfer impedance, we will remove other sources instead of the input source or input supply voltage. For this case, there is a one supply voltage in our circuit that is associated with mesh 1, through which I1 current flows. Okay, so if we consider the ratio of E1 and I1, then tell me what will be the input impedance, what will be the expression of this ratio in terms of given impedance Z1, Z2 and Z3. Z1, Z2 and Z3. You see Z1 impedance is connected in series with the parallel combination of Z2 and Z3, parallel combination of Z3 and series combination of Z2 and ZR. Okay, let me write this thing. We can write the overall transfer impedance equal to Z1 Z1 series combination of Z3 and parallel combination of with Z2 and ZR. Everyone try to understand this point. The input impedance or U1 by I1 will be equal to, if we represent in terms of the given impedance of the circuit Z1, Z2, Z3, ZR, where ZR is the load impedance. So we can write Z1 Z1 plus Z3 product Z3 Z2 ZR, the Z3 divided by their sum. Everyone see Z2 plus Z load impedance ZR divided by total impedance Z3 plus Z2 plus ZR. Okay, this is the expression of driving point impedance. You see, the input impedance for this circuit is the ratio of supply voltage E1 and the current who is flowing through mesh or loop 1 I1 current. So we can write input impedance or driving point impedance equal to E1 by I1. If we want to express input impedance in terms of impedances associated with the given circuit, then we can write this thing, that the overall impedance is equal to the sum of Z1 impedance and the equivalent impedance of the parallel combination Z3 and Z2 plus ZR. So that's why I have written the driving point and input impedance is equal to Z1 plus Z3 into Z2 plus ZR divided by Z3 plus Z2 plus ZR. If anyone has any doubt to derive the expression of input impedance, you write your confusion in chat box. Okay. Now, if I ask you what is the expression of, or what will be the expression of input or driving point admittance, so you can write 1 by Z in, that is nothing but this thing you will get, then driving point admittance equal to 1 by Z in, 1 by Z in, and that is equal to, you can write the reciprocal of this thing, reciprocal of the simplified form. You just multiply Z1 into Z3, that you will get ultimate Z3 plus Z2 plus ZR divided by Z1 into Z3 plus Z2 plus ZR, okay, plus Z3 into Z2 plus ZR, Z2 plus ZR divided by okay, this Z3 plus Z2 plus ZR divided by the product of Z1, the sum of product of Z1 Z3 Z2 ZR and Z3 Z2 ZR. Okay, so now let me derive the expression of transfer impedance, transfer impedance Z sorry, Z T T 1 2. We have considered to put here the 1 2. So we can write the expression. This expression will be, first you write in terms of current and voltage. Current and voltage. After that you express this thing in terms of impedances, given impedances. So this thing you can write. Let me tell you. Okay, so how do you derive the expression of transfer impedance? Expression of transfer impedance. You see the transfer impedance is nothing but the ratio of input supply voltage. I mean the supply voltage, external supply voltage, which is associated with loop 1, and the current I2, which is actually flowing through loop 2 or mesh 2. Now our objective is to derive the expression of transfer impedance in terms of given impedances Z1, Z2 and Z3. So what is your first actually approach? Everyone first write the KVL, write the mesh equation for loop 1 and loop 2. Mesh equation means the KVL, Kirchhoff voltage law you apply. The total voltage drop across mesh 1 and across mesh 2. You write the expression of total voltage drop for loop 1 and loop 2. To derive the expression of transfer impedance, we need to derive the mesh equation for two consecutive or two meshes corresponding to loop 1 and loop 2, or for current I1 and I2. Okay, so if we write mesh equation for loop 1, we can write by applying KVL or mesh equation for loop 1. We can write for loop 1, that means current I2 corresponding to current I2 not I1, sorry, I1. So you can write for I1 the loop equation will be, for the given circuit, E1 equal to the sum of voltage drop across Z1 and Z3 impedances. So Z1 I1 plus Z3 into I1 minus I2. Everyone, you write the mesh equation. For loop 1. To E1, you can write E1 equal to Z1 I1 plus Z3 I1 minus Z3 I2. Okay, E1 supply voltage. So now you write the loop equation for loop 2 or corresponding to current I2. For loop 2 or corresponding to current I2, loop equation to current I2. We can write that Z2 I2 plus Z3 I2 minus I1 equal to 0, because for loop 2 there is no supply voltage. 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 So we can write Z2 I2 plus Z3 Z2 I2 plus Z3 I2 minus Z1 I1. Now everyone see that the expression driving point impedance expression has two quantity U1 and I2. So from loop 2 we can write the expression of I1 in terms of I2. After getting the expression of I1 in terms of I2, we will put expression of I1 in the expression for loop 1. So let me write it. So from this expression we can write, that I1 equal to how much? Z2 I2 plus minus Z3 sorry, let me write plus Z3 I1 equal to I2 divided by whole. Actually you take whole of this thing and divided by Z3. Everyone see that from the expression of from the mesh equation of loop 2 we can obtain the I current expression in terms of I2 current and impedances. So I1 equal to, we can write Z2 I2 plus Z3 I2 divided by Z3. Okay, now let me put the expression of I1 in this equation, mean loop equation 1. So if we replace I1 here, Z1 I1 equal to, we can write Z2 I2 plus Z3 I2 divided by Z3. Okay, plus Z3 into Z2 I2 plus Z3 I2. Okay, Z3 I1 equal to Z12 plus Z divided by whole thing divided by Z3 and then a minus I2, and you write this whole things is divided by Z3. Everyone see the expression. If is there any error, please let me know. Okay, so first we have derived the expression of currents I1 in terms of I2 and given impedances. After that we have inserted the expression of I1 or value of I1 in loop equation for loop 1 through which I current flow. After that you just simplify this thing and you write the ratio of U1 by I2. You will get the final expression for transferred impedance. If we simplify this equation, and we can write this equal to, if we I2 if we take common I2, then we can write U1 by I2 is equal to a expression like this. So you can get final expression will be Z1 Z2 plus Z2 Z3 plus Z3 Z1 plus okay, E1 I2. Okay, I have made a mistake here for E1 I2. E1 I2 will be Z. Let me write this thing correctly. Z1 plus Z3 into Z2 plus ZR plus Z3 divided by Z3 minus Z3. Okay, minus Z3. So E1 by I2 you will get such type of expression Z1 plus Z3 into Z2 plus ZR plus Z3 divided by Z3, the product of Z1 plus Z3, Z2 plus ZR plus Z3 by Z3 minus Z3. Okay, now you simplify this thing and you will get the ultimate expression of this transfer impedance. You will get the expression of transfer impedance Z1 Z2 plus Z2 Z3 plus Z3 Z1 plus ZR into Z1 plus Z3 divided by this whole thing divided by 3 Z3. Okay, so everyone see the final expression of transfer impedance. If you have any doubt or if you face any difficulty to derive the expression of transfer impedance, please let me know. This is straightforward approach. First you write the loop equation for loop 1 and loop 2. I mean loop equation for current I1 and current I2. After that you derive the expression of I1 in terms of I2 and Z1 Z2 Z3, and later on you put this expression, the value of I1 in a loop equation corresponding to I1 current, and then you simplify that expression and you will get finally the transferred impedance expression like this: Z1 Z2 plus Z2 Z3 plus Z3 Z1 plus ZR into Z1 plus Z3 divided by Z3. Okay, now tell me, what are the units of impedance and admittance? Now you can derive the expression of transferred admittance. Transferred admittance expression will be the reciprocal of ZT12, mean transfer impedance. So you can derive the expression of transfer impedance. So therefore you can derive or you can calculate the value of transfer impedance as well as driving point impedance for any given circuit. On the other hand, if you know the values of transfer impedance and driving point impedance, then you can calculate the value of driving point impedance as well as transfer impedance. One thing everyone remember, that the units of these parameters of this quantity impedance are ohms, and for admittance is mho. The unit of impedance is ohm and the unit of admittance is mho. So everyone can calculate the expression of this parameter of these quantities for any given circuit. Yes, Nivedita, you are correct. Yes, thank you, Nivedita. So now you have a good concept. What are the significance or the importance of this quantity, driving point impedance as well as transfer impedance and admittance, and how do you derive the expression or value for this quantity or for this parameter for a given circuit. Now tell me tell me one problem. Everyone solve this problem yourself. Okay, let me show you one problem, and everyone solve this problem using a network transformation concept. That topic we have covered in last class, star delta conversion, delta star conversion. But in previous class we have considered the circuit having only passive element resistances. Now I will give you one problem. The circuit consists of impedances instead of resistances. Okay, everyone, first see the problem, first read the problem carefully. After that you solve this problem using the concept of source transformation, delta to T or delta to star or star to delta, which one is required, you use that one, I mean formula, and calculate the values of impedances for this circuit. The question is that in each branch of a delta circuit has impedance root 3 into Z. Root 3 into Z, Z is nothing but impedance. Then each branch of the equivalent Y circuit, mean T circuit. Y circuit, you know, it is also known as T circuit, has impedance. What will be the value of impedance for each branch of the T or Y circuit? So you first write or you first obtain the value of T circuit elements impedance by using the value of delta circuit elements. Everyone solve it yourself and tell me the answer. In last class we have discussed source, we have discussed the concept of source conversion. Everyone use that concept, source conversion concept, and write the expression of impedance for Y circuit. So let me write the expression of Y circuit impedance in terms of Z circuit impedance. So you know that Z1, if we consider Z1, Z2, Z3 are impedance of Y circuit element, and ZA, ZB, ZC are impedance of delta circuit element, then we can write Z1 is nothing but the ratio of the product of its product of ZB divided by ZA plus ZB plus ZC. Okay, here we have considered the impedances for Y or T network are Z1, Z2, Z3 respectively, and for delta network ZA, ZB, ZC all are capital. So we know that Z1 for a T network element is equal to the ratio of product of the adjacent delta network impedance divided by the sum of all impedance associated with delta network. So therefore we can write, if we consider ZA, ZB are the adjacent arms of Z1 element for T network, then we can write the product of ZA, ZB divided by ZA plus ZB, ZC. Now let me write the expression for Z2. Z2 is nothing but equal to, you write Z B ZC divided by ZA plus ZB plus ZC. Similarly, we can write Z3 equal to ZC into ZA divided by ZA plus B plus ZC. Okay. Now we know that the value of ZA, ZB, ZC are same, and it is equal to root 3 by Z, root 3 Z. So we can write sorry, root 3 Z plus, that means you will get 3 root 3 Z. If you 3 root 3 Z, the sum will be 3 root 3 Z divided by, sorry, I written full, this will be root 3 Z square, 3 Z square, Z square divided by 3 root 3 Z, 3 root 3 Z. You write this thing as Z square. Therefore we will ultimately get the value of Z1 is equal to 3 root 3. That means Z by how much? Root 3. Z by root 3. Everyone solve it yourself. So therefore Z1 is equal to Z by root 3. Z by root 3. You just put the values of ZA, ZB, ZC, which are nothing but root 3 Z. It is given. The impedance value of individual arms for a delta network is root 3 Z. So you just replace ZA, ZB, ZC, you replace root 3 Z. Root 3 Z. So 3 Z square, root 3 Z into root 3 Z, you will get 3 Z square divided by root 3 Z plus root 3 Z plus root 3 Z, you will get 3 root 3 Z. So 3 is cancel out, you will get, and Z square by Z by root 3. So similarly you will get the expression of Z to Z3 equal to Z by root 3 because all ZB, ZC, ZA are same, root 3 Z. Okay. Any doubt for this circuit? So if in exam, in any type of competitive exam, you face such type of circuit or such type of problem, don't worry, you just use the basic concept of source of network conversion, delta star pi t, that concept, and you simplify that equation, that circuit, you will get the result. Now let me give you a very simple problem that the circuit consists of resistances only, and you solve it yourself and tell me the answer. Okay, everyone got? Thank you. Orkodim, Nivedita. Okay, and everyone try to understand the concept of network conversion, source conversion, etc. which we will use to solve such type of problems. Now you solve another problem. For this problem the circuit consists of resistances only, and you solve it yourself and tell me the values of R1, R2, R3. In this circuit, you see a delta network consists of three resistances having values 50 ohm, 30 ohm, and 15 ohm. You convert this delta network into a T networks, and you see the values of T networks arms are R1, R2, R3. Your objective is to calculate the value of R1, R2, R3 by using the values of delta network resistances. I mean 50 ohms, 30 ohm, and 15 ohm. Everyone solve the given problem, present problem yourself, and you write the values of R1, R2, R3 in chat box. Okay, so everyone solve this thing using the same concept. You see the expression of R1 for T network is equal to the ratio of the product of resistance 50 ohm and 30 ohm divided by the sum of all resistances for delta network. That means 50 plus 30, 80 plus 50, 95. So for R1 you will get 150 by, let me write this thing here, and you calculate the values of another two resistance. So R1 equal to not 50 ohm, 5 ohms, 5 ohm into 3 or 30 ohm into 30 ohm, so you will get 150 ohm. Let me write it 5 into 30 divided by sum of 5 plus 30 plus 15. So we can write it is equal to 150 divided by 30 plus 15, 45 plus 50, 50. Okay, 40, 50. So that means you will get ultimate 3 ohms, 3 ohm. The value of R1 resistance for T network is 3 ohms. So everyone calculate the value of other two resistance R2 and R3. R2 and R3. Okay. So R1 is nothing but the 3 ohm. Yes, Orkodip, 3 ohm, right? And in the similar way you solve you calculate the values of R2 and R3. Okay, everyone write the values of R2, R3 in chat box after solving the problems. Nivedita, R2 9 ohms. Okay, thank you. Arkodim 9 ohms, thank you. Where are other students? Write the values of R1, R2, R3 in chat box. Okay, let me. Okay. So now we will write the expression of Z1, Z2, Z3. Okay, you will do it yourself. Okay, I will give you to sim R3 1.5. Yes, Arkodeep, your answer is correct. Everyone solve this. So one thing everyone remember that Ishika goes. Thank you, Ishika. Remember that in today's class, Sweetie Kumar. Thank you, Sweetie Amit. Thank you, everyone. In previous class and also in today's class, we have discussed about the network conversion, I mean delta to T or T to delta, in terms of resistance and impedances. Resistance and impedances. If anyone have any doubt regarding the derivation of impedance for T network or delta network, you let me know. Otherwise, I will discuss another problems. Everyone derive the expression of impedances for T network and delta network and make them equal, and after that you simplify those equation, you will get the expression of Z1 Z2 Z3 in terms of ZA ZB ZC, or expression of ZA ZB ZC in terms of Z1 Z2 Z3, because we have already discussed these things for resistive circuit R1 R2 R3. In the similar manner or similar way, you can derive the expression of impedances for two types of network, delta or pi. Okay, if you face any problem, you let me know. Okay, now I will give you two basic problems associated with this with the topics whatever we have covered so far and in today's class. Okay, from next class we will discuss a new topic, that is theorems, superposition or Thevenin, etc. we will discuss. But today you solve to simple problem, very simple problem which are associated with Kirchhoff laws, especially voltage law, current law, mesh equation, loop equation, node analysis, etc. whatever we have discussed so far, source conversion, independent dependent source, branch, loop, nodes. If anyone has any doubt regarding the topics whatever we have discussed so far in today's class, let me know. Okay, because from next class we will start a new topic, that means DC theorems, including a superposition, Thevenin's, Norton's, reciprocity, compensation, or a maximum power transfer theorem. You have little bit concept or knowledge about maximum, superposition, Thevenin, Norton. So we will discuss those theorems in details from next class. Okay, now everyone solve this one, the problem you see in the screen. You see a circuit having few sources. The circuit consists of several sources. The question is that you tell me the value of voltage E. The value of voltage E. Everyone use the concept either KCL, KVL, mesh analysis, loop analysis, node analysis, matrix form, whatever you can use to solve this one. But everyone remember that you always use that formula or equation which help you to solve the problem in less time. You always consider the time to solve the problem. You always select or choose the formula or concept which will help you to solve the problem in very less time. Okay, so now you see this is a problem. The circuit consists of several voltage source, and you see there are two actually arms. If you consider two path, you can consider one path like this 0 volt, 1 volt, E, 5 volt, 10 volt, and another path you can consider V2, 2 volt, E, 4 volt, V1. If you consider the left leftmost mean this path, leftmost path, then you can see that there are total three elements are unknown, three quantity v2 e v1. But if we consider this path, right side path, that is 0 volt, 1 volt, e 5 volt, 10 volt, this path, then we can easily then we can say that for this path only one quantity is unknown, that is e. So therefore if we consider the left side path, then we need to calculate the values of three unknown parameter v, v2, v1, e. But if we consider right side path, then we need to calculate the one unknown parameter e, and our objective and the question is that you calculate the value e. So therefore to solve this problem we will consider the right side path and we will apply KVL. We will apply Kirchhoff voltage law. The total voltage drop for this path we need to write. So let me write and everyone solve it yourself and tell me the value of E, and let me solve it and you compare your result with the result which one I will obtain. So if we consider right side path, we can write 0 volt minus 1 volt minus E minus 5 volt minus 10 volt. So therefore equal to 0. Therefore we can write E equal to nothing but minus 16 volt. Minus 16 volt. Okay, everyone see that. Everyone see that. The value of E is minus 16 volt. I have already sent you the PDF for KVL KCL, and in that PDF you see there is a subtopic determination of source sign, determination of sign, source supply voltage or voltage drop across elements for a given circuit. If you use that concept, then you can easily write this thing. You consider the right side path and use KVL, Kirchhoff voltage law, then you can write the expression of E is nothing but minus 16 volt. Any doubt? Okay, I hope everyone understood the concept. Here we have used KVL. By applying KVL, by applying KVL for right side path, or right side loop, you can write for right side loop. Okay, now everyone, Nivedita, then what will be the value of E? Tell me, Nivedita, what will be the value of E? You solve it and tell me what will be the value of E. Nivedita, you have any confusion? Okay, Nivedita, thank you. I think that you have confusion. You have confusion regarding the solution of this problem. This is a simple problem. In a exam, such type of problem come. Okay, Nivedita, thank you. Now I will give you another problem. You solve this problem using the concept. Using the concept whatever we have covered so far. Okay, this is also a very simple problem, but you need to find out the formula or laws which one is suitable to solve this problem. Everyone solve it. The next problem, everyone solve it yourself and tell me the answer of this problem. Okay, tell me the answer of this problem. Arijit Acharya 1 e minus 10 minus, why Arijit? Plus 1 plus e minus 10 minus 5, why? You see, when you travel from positive side to negative side of a source, then voltage actually increase or decrease? Decrease. Negative sign will appear before the source. So minus 1 minus e minus 10 minus 5 equal to 0 you will get. Arijit, correct your answer. You consider the concept of sign for voltage sources, supply voltage sources, not voltage drop across the element. For the previous problem, you see that the circuit consists of several supply voltages. So that's why you consider negative sign before them to solve this problem. Everyone solve the present one. You see a circuit consists of several resistances and one supply voltage is given. Question is that you calculate the voltage drop across these resistance 4 ohm. What will be the voltage drop across 4 ohm resistance, and it is denoted as E naught, small e naught, and supply voltage is 2 volt. Anyone can tell me how do you solve this one? Anyone tell me how do you solve the present problem? Very simple problem. You use the basic concept of there are two types of law, KCL and KVL. Use any one of this, of the two, but you try to select that one which will help you to solve this problem easily. It will. Yes, Nivedita, you use KCL. KCL will help you to solve this problem in very less time. So let you use KCL. So then you tell me the value of E naught. You see that the voltage drop across this actually terminal, this and this and this, between this there is a 4 ohm resistance, and question is that what will be the voltage drop across this resistance. So KCL. So if you use KCL, then you see 12 volt supply voltage, 4 ohm resistance is connected in series with this 12 volt. So this current will be divided into two parts, this and that. If you consider I1, I2, so this I current is sum of this I1 and I2. So you just use KCL and solve this problem. If you know the value of current, then you can easily calculate the, or you can say this is V volt. You can consider the voltage here V. So you can write 12 volt minus V by 4. Let me write it. You solve yourself. First 12 volt 8 Sweetie Kumari, 12 volt 814 I2. No Sweetie, this is not the approach. Let me write it. Okay, no problem. Let me write it and then everyone solve, simplify this equation. You consider the voltage drop across 4 ohm resistance V. Okay, consider the voltage drops across a 4 ohm resistance is capital V. Then we can write by applying KCL at this point, this node. Okay, we can write 12 volt minus capital V divided by this 4 ohm resistance. This 4 ohm resistance 4 equal to capital V by 4. This current, this I1 current, suppose plus you can write capital V capital V divided by the sum of these two resistance, 2 plus 2 4 ohm resistance, 2 plus 2 4 ohm resistance. So so ultimately you will get 12 minus capital V equal to capital V plus capital V. The 4 you see on both sides 4 are in denominator, so they will be cancelled out. So you can write 3 capital V equal to 12. So ultimate you will get a capital V equal to 4 volt. So you write this thing as VA. Okay, is better V1 because V is the expression of voltage. So you change it V1 V1. You write here also V1 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 equal to 4 volt. So okay, so if such type of problems come in exam or any competitive exam, you solve it using the fundamental concept. Everyone try to use the concept KCL or KVL or mesh equation, loop equation, source transformation, etc. Okay, so I will give you assignment for the topics whatever we have covered, okay, so far and in today's class. Okay, I will give you an assignment and I will also provide you PDF for those topics discussed so far. Okay, I mean matrix from mesh equation using matrix from and some problem. I will provide you that PDF. Okay, so please everyone try to understand the concept and solve many problems associated with circuit theory. Then you can easily find out or easily determine the approach, mean formula or law to solve any given problem. You solve if possible you solve more problems for this topic, and if you face any problem to solve any difficulties to solve those problems, you let me know. Thank you everyone. And I will provide the PDF of today's class also, don't worry. Everyone write your name and ID number in chat box. Who left, actually who forget to write name and ID number in chat box, please write it here for your attendance purpose.